In this shot, you can tell the pilot experienced severe but survivable impact loads, but was effectively restrained by the shoulder harness. During the controlled impact demonstration, large amounts of liquid AMK evidently flowed over the fuselage, keeping the temperature relatively cool. Because of the lower heat, the AMK fireball did not burn through the fuselage and ignite the interior materials, even though insulation had been removed to install test instrument lines. The only other way for AMK to fail and then burn is to give it an intense, continuous ignition source. In the CID test, the destroyed engine provided just such a source. It stayed with the fuselage throughout most of the slide and was located right at the fuel release point. So, how bad was the fire? Viewing the CID from impact to final rest shows the external fireball about the fuselage lasted roughly 9 seconds. Anyone who witnessed the CID test or saw the televised shots of it will probably have the same question. Why did the AMK-fueled plane have such a large fire? The first cutter entered the right inboard engine at about the 7th stage of the compressor. It slashed through the engine, broke free, then tore through the underside of the wing, inboard of the engine, releasing a massive volume of fuel. At approximately 1/10 of a second after impact, the first ignition occurred on the inboard side of this engine. The highly unlikely had happened. Post-crash examination of this engine showed compressor rotation stopped instantaneously. Why ignition occurred requires a description of the damage caused by this impact. From the moment the CID aircraft smashed down onto the desert floor, the model accident was gone. The plane struck the ground somewhat short of the target, with the left outboard engine low and yawed to the left. It remained yawed to the left as it slid into the wing opening cutters.
The Impact Dynamics Research Facility accommodates a variety of testing. Once used to test lunar modules for the Apollo project, today the IDRF is used to evaluate external fuel systems, conduct full-scale helicopter crash tests, develop and demonstrate precision delivery pallets, test cockpit escape modules, crash test composite fuselage frames and subfloor beams, as well as perform NASA general aviation testing.